Thank you. So right, yeah, we've got the chairs coming out for the next session, a panel discussion on WebAssembly for Web 3.0. Now, most of you probably already know, but WebAssembly, it was a project that started in 2015, and it's designed to be a portable yet performant language. So, you know, obviously taking its place in web browsers quite prominently. Some people call it JavaScript done right. And at the moment, it's possible to compile to it from C and C++, but soon we'll have Rust and some of the .NET family of languages going straight to WebAssembly. And once garbage collection's in there, I'm sure we'll see Java, C#, and Go being included there. So please welcome on stage for a discussion about WebAssembly for 3.0. Alex Beregszaszi, sorry Alex, Peter Czaban, Sergei Shulepov, and Rettig. Thank you very much.
Hi everybody. Are the mics working? Sounds like we have sound. That's a good start. Cool. So on behalf of all the panelists, we're all very excited about the WebAssembly technology, and we're all very excited to share with you guys some of the work that we've been doing within the Ethereum Foundation, and to hear about the work that Sergei and his team have been doing at Parity and within the Polkadot project. So why don't we start with introductions? Would you mind just sharing who you are, what your kind of role in the ecosystem is, and additionally, I guess just what excites you about WebAssembly as a technology? Peter, you can kick off.
Yeah, sure. So I'm Peter from the Web3 Foundation, and as I mentioned in my talk on Monday, WebAssembly is really one of the first formats that is emerging that can allow us to have a universal way to describe computations for the decentralized web, and first for the web, but also for decentralized web. And there is so many different kind of elements that can build upon that. So we see of course smart contracts that can be verified reliably by all the nodes in the network, but also chains themselves and oracles and heavy computations and many other things. So we see it as this universal language in which everyone will be able to describe computation that is understood by the network.
I'm Alex, and I work at the Ethereum Foundation mostly on Solidity and as well as part of the Ewasm team. And I share the excitement with Peter regarding the universality of Wasm, but I take it one step even further because I think it can be also applied well outside of the web and the blockchain space. So one example I always like, and what I'm actually personally interested in, is just not even deterministic, just measured computation in general. So for example, today cloud execution is measured by time somehow, and all of that could be maybe aided by Wasm, measured by Wasm, and the user could be charged accordingly. So I think just Wasm can be so universally applied across all the computational problems people have, maybe not as the actual thing which is executed, but like a transmission layer. I think that's super exciting.
Yeah. So yeah, I'm working for Parity, and I'm working on smart contracts nowadays for Substrate, and I was always excited about programming languages and virtual machines. I even tried to implement my own JVM, but don't ask me about that. And and when I discovered about WebAssembly, I was so excited because it was really something new. It allows you to describe computation like very it's deterministic, and you can describe computations in a very performant way to execute them, and yeah, that's really something new.
Cool. Yeah, so I'm Lane Rettig. I'm on the Ewasm team with Alex. I guess my pet project within that team has been assembly script, which maybe we'll circle back to a bit later. One of the cool things about Wasm and that excites me about it, especially as a platform for Web3 and for Ethereum in particular, is that it really vastly opens the scope of different programming languages and frameworks that can be used to write smart contracts. So yeah, we'll put that as a topic to come back to. But I just want to agree with what Sergei said a moment ago, that this ability to describe computation in an abstract, platform-independent way, it takes some time. Like, it's taken me some time to get my head around exactly what that means and why it's so exciting, but I think it's an extraordinarily powerful idea. I think we've just begun to understand the implications of this. And for me in particular, the idea that if you have the same framework, the same virtual machine running on-chain and off-chain, right? So we can run applications near native speed on a variety of devices that are compiled to Wasm, and in the future we'll have that Wasm support on Polkadot and on Ethereum and many other chains. That opens the door for enormous, exciting possibilities about kind of blurring the line a bit between what runs on-chain and off-chain. So again, this is something that we can circle back to. Cool. So let's dive in a little bit more, maybe starting with a tiny bit of history. So Alex, if you wouldn't mind kicking off, I'd love to hear about just the birth of the Ewasm project and how Wasm was chosen as the VM and the execution engine for Ethereum 2.0.
Yeah, that was a while ago. It was actually not too long after Ethereum was launched. So Frontier was launched like July 2015, and Ewasm, back then called EVM 2.0, was like kicked off January 2016, but the prototyping started like end of December 2015, so that's like 4 months after Ethereum and the EVM was launched. And practically it was sparked from the fact that EVM was designed to be that it should be extended and improved over time. And I think this tiny little team of Martin, BZ, and me, we maybe didn't fully believe that all of that improvement's gonna come in time. And maybe it seems that we were right in the sense that those improvements didn't came. But one major issue which we identified at that point was like this fundamental design of EVM of being like 256-bit oriented, which doesn't really reflect any current machine out there. So we looked at alternatives, and we actually looked at all the different VMs which were available at the time. So obviously started with the JVM and looked at pros and cons. Looked at CLR, which is the VM for C# and the .NET ecosystem. Looked at even the Row VM, a bunch of others, and then we also came across WebAssembly, which was still in its early stages, but in hindsight, the design of WebAssembly starting 2016 didn't like substantially change from today. But it was still like in early days. Nobody was sure whether it's going to succeed, as in will it be launched across the browsers, which it did, but we weren't sure. So we listed all these pros and cons, and one of the actual reasons we decided with WebAssembly was that it was early, it's in development, and we felt like that we can have a word in the development if we identify an issue which would prevent it from being used in a blockchain context. Luckily, we actually didn't really identify any major issue, so even though we did have the opportunity to have a word, we didn't need to like speak up too much. But we did interact with the Wasm community, which anybody is able to because it's an open community. So that's how it started. We looked at all these different VMs. Wasm looked like the best, and we were also really excited about like the Web first and the Web3 ideology. So it looked like a really good fit, and we had the opportunity to have an influence on it, and it seemed to be a really good decision.
So just to get everyone on the same page, where does Wasm or Ewasm sit in the Ethereum roadmap today? And what is the path forward to Ethereum 2.0 or other possibilities?
Yeah, the question everybody's asking, and it's really hard to answer. as for us, for the Ewasm team, obviously we just really want to have it on the mainnet. We want to have it out there and have people to use it. So that's still our main driving force. And to get there, we are launching a testnet. And then we really want to have it introduced as a hard fork to the mainnet. But that requires a lot of work. So maybe we're just going to first try to introduce a subset of it for a specific thing called like precompiles, and maybe make introduction of precompiles, new precompiles easier. So probably that's like the next step. But as we can see, that by the example of the Constantinople hard fork, that rolling out hard forks may take longer than expected. It's really hard to put a time on it. Ideally, I personally would like to have it in a year, but that's very likely unrealistic. So another way to introduce Ewasm to like Ethereum is through Shasper, and that's been like a big thing. The Shasper team was really interested in to use Wasum as an execution engine. But then again, I have even less visibility on how long Shasper going to take. But yeah, these are like the two. We are crushing both sides. We are trying to introduce it wherever possible and essentially everywhere.
Cool, that's exciting. Great, so I guess, Sergei, same question to you. Can you share with us a little bit about the history of sort of the choice of Wasum for Parity and for Polkadot rather, and where the role that Wasum plays in the Polkadot roadmap?
So yeah, unfortunately, I can't share with you like how it was from historic perspective, because when I joined, all this was already set in stone, so it was pretty much recently, I would say. Yeah, but at the same time, I actually can imagine. It's just because I can see it like any other options right on the horizon. Like the WebAssembly is most obvious choice for that kind of thing, because, for example, we could not use EVM, for example, for Polkadot for describing the blockchain logic, because it's too tailored for for the start. It's too tailored for the EVM Ethereum account model, for example. And it's also doesn't have that good performance, and yeah, and it's not that extensible like WebAssembly. Yeah.
Makes sense. Yeah, so we saw Gavin here yesterday deploy a chain on Polkadot substrate from scratch, and then see if I can get the terminology right here. I'm still learning Polkadot, but upgrade the runtime in real time, right? So he added a module or something and made a change to it, and then clicked a button and uploaded a new Wasm binary. So he made the change in Rust, compiled it to Wasm, uploaded that. So that, I guess Wasm enables that. That would be difficult to do with another framework.
Yeah, exactly.
Yeah. So, and it started a bit earlier with first experimentations with the enabling Wasm VM for Kovan network, where it was kind of experimented with, and the initial metering was introduced. But generally speaking, for the kind of Web3 ecosystem and the Polkadot ecosystem, there is kind of a lot of kind of places where it can be used. So obviously, as you mentioned, kind of substrate itself, it describes this the state machine or the runtime that tells the chain like what is its actual functionality in Wasm, so that basically anyone that just runs a Wasm interpreter is able to execute it, is able to run whichever state machine or whichever functionality of a chain can be described using it, which is very general. So that makes it possible to have basically the same kind of node run many different kinds of chains, and also the same kind of node at one point in time run one kind of logic, and then later on run another kind of logic. So this is what we've seen, where kind of one chain can kind of transform into something completely new, just thanks to the fact that every node in the network is able to understand the language in which the computation is being described. And this property can, of course, be now applied not only to validate kind of smart contracts, but actually like the whole logic of the chain. So basically validate blockchains, generally speaking. And then even further, there is projects that work on, that also plug into the whole network that, for instance, perform some computation on data from the real world. So, for instance, oracles that request the data and then do some sort of predictable computation on it and then inject it on chain. And then because everyone does the same predictable computation, you can have this reliable transformation applied to the data. Or if you want to have an off-chain components in the whole ecosystem, and you also want to run some more computations, and only upon dispute actually try to do something, and in most cases just execute them freely without running them on chain. Then you can also make use of Wasm in order to kind of to be sure that everyone that was supposed to execute computation was going to execute it in the right way, and if they didn't, then arrived at the exact place where there was some disagreement. So this kind of universal ability to interpret this computation language becomes important across the whole network.
That sounds a lot like what Trubit is doing.
Yeah, exactly. Trubit or Golem is another application,
right.
that would be maybe validating the computations. For oracles, Chainlink is a project that makes use of Wasm in order to transform real-world data. Yeah.
Cool. Thank you. That's I agree. That's one of the most exciting properties of Wasm, that it allows those sorts of things to happen on-chain, off-chain. I'm going to preempt a question that we usually get from the audience, and that is, to what extent is the goal of Wasm, Ewasm, Pwasm running things inside the web browser? Like, will we ever see a full Polkadot or Ethereum node inside a browser compiled to Wasm?
Yeah, so I don't think that there is a lot of sense of compiling full node, compiling and running full node inside of browser, because it's usually full nodes require a lot of resources, especially like especially disk and stuff like that. And like browsers don't give you much of leeway in that sense. But on the other hand, we can, we surely can compile light clients to WebAssembly, and this is actually a very good thing. So for now, people usually using Infura for making their D apps, but it's like an intermediate step. Like I think that in the future, people should use less centralized solutions, such as running light client directly in their D app.
So even you have two different parts to it, because the question was whether write clients in Wasm in the browser. So you have two different options as well. You may just write a light client in whatever language the browser supports, which is just JavaScript. But if your blockchain or consensus engine uses Wasm, you don't have to write the VM anymore. You just need to write the logic in your light client, and you can use the Wasm VM in the browser. So that certainly helps. I don't think anybody is actually focusing on that. But since all these new blockchain/consensus projects all utilize Wasm as the execution layer, it makes it super easy for light clients to be implemented in a browser. But you could also write a lot of this light client functionality in something compiled to Wasm itself and be used in the browser, thereby reducing the actual effort needed to write the light client for the browser specifically.
Just to be clear, though, sort of browser support is not one of the primary goals of I can speak more confidently about the Ewasm project, but I'm assuming it's also for Parity not one of the primary goals of Wasum, the Wasum project, right?
You mean for substrate or Polkadot?
Sure.
So, like, I would not say that it's primary goal, yeah. But, like, for me personally, it's something that at least desirable.
Yeah. And the title is WebAssembly for Web3, so there is probably many, like as mentioned, like there is many different ways in which it can be applied. And this is, I think, Parity is developing Feather, a light client that compiles to Wasm and can run in the browser for the Ethereum network, and then later potentially for other networks. But yeah, Wasm makes it much easier to have all sorts of protocols running in the browser. So this is kind of you can use some of the building blocks that are already there, and I think already Signal protocol I think has an implementation that compiles to Wasm, and all those kind of more crypto-heavy things will be much easier and much more performant if they are implemented in Wasm. And then of course if then the logic, the chain logic itself, or any sort of validation logic is also Wasm, then it's of course much easier to execute in the browser. So then it allows you to not have to put in, download any special software potentially, or an extension to your browser, but it can actually run natively in the browser. Of course, there are some limitations in terms of like the kind of the sandboxing that the browser does that make it pretty hard maybe to connect to a peer-to-peer network or to get certain I/O. But still, it makes it much easier to access a lot of people for which it may have been a large barrier currently to access decentralized networks.
And when we say browser, we tend to have this visualization of a desktop web browser running on like a laptop or a desktop computer. But I just want to reemphasize, for me personally, one of the most exciting things about Wasm is that it runs effectively natively anywhere. The way I think about it is sort of anywhere that JavaScript runs today, right? So that obviously includes an array of mobile devices and these resource-constrained devices. But I mean, JavaScript is the most sort of common and popular programming language in the world for a reason, right? It runs, at least we're moving into a world where it will run in satellites and in cars and connected devices and toaster ovens and everything. So I have this vision that we have this single virtual machine, right, that's shared across all these platforms.
Yeah, absolutely.
Alex, so back to the goals point. If sort of web support is not one of the primary goals of the project, what are the main goals of the Ewasm project?
Well, basically, the main goal is to have like a much better foundation for the execution engine than what we have today. So the main goal of EVM was that it's tiny, everybody can understand it. It has a small surface. We, as in the community, control it, and we can extend it. But I think extending it, maybe this goal didn't really turn out to be working. And it seems that Wasm provides a much better foundation to all of this, because it seems to be better designed with extensibility in mind. So with Ewasm, the goal is to have this better foundation, which is also more performant, and sets like a better foundation for extensibility in the future. I don't think we really have anything else. For a long while, the main point was that it gives the speed bump, and therefore it's like a scaling project, but I don't think it is. That's not the main case. But one other important point this brings is Wasm has such a broad language support, and more importantly, besides languages, it has a lot of tooling around it, and a lot of security tooling for these languages, which is something Ethereum was missing for a long while. It starts to get way better now. So like for Ethereum-specific languages, EVM-specific languages, there are a lot more security tools now. But Wasm, it's such a way bigger ecosystem than EVM ever probably going to be, that it's way more likely that security-related tools and developer experience-related tools will be available at a much bigger scale through WebAssembly. So that's the door we're opening.
Mm-hmm.
And
yeah.
Sergei, for Polkadot.
I just wanted to add something to what Alex just did say. So it's not only about tooling, but sharing the knowledge in general. For example, we can share something about like technology of compiler development, like directly with like browser vendors and something like that. So I had discussions about compiling Wasm untrusted Wasm code with some folks from the like Wasm compiler community, and they actually very interested in like such compilers, and they can share knowledge how to build one with our Web3 community. Yeah, so that's really cool.
I agree. That's really powerful, right? In the Ethereum and EVM world, we're sort of in a little bubble, and the degree to which we can communicate. This is actually very interesting to me, is framing it around communication, right? Wasm is a virtual machine, and it's sort of this universal computing platform, but it's actually more than that. It's sort of a common language that we can use to describe, right, as you said, computation in an abstract sense, but share knowledge as well. And so by escaping from this EVM bubble and sort of embracing and becoming a part of the wider Wasm world, I agree completely. That's a fantastic point, that we can all share an enormous amount of knowledge.
Yeah. And there is already research teams that are working on formal verification of Wasm, even without us trying to persuade them, hey, you should be doing it, because they are doing it for the web, and now we can use those tools. So we spoke to some group at INRIA that is working on F-star formal verification, where they compile Wasm to F-star. So yeah, it's just much easier, and there is so many tools that we can leverage, not only that will be developed for Wasm, because it will probably become something that is popular for the web, but also for all the languages that are then that can compile to Wasm or work with Wasm.
So on the topic of languages, this is really interesting. There are two schools of thought here, at least in the Ethereum world, and I suspect it would be similar in sort of the Polkadot world. The first school of thought is that blockchains are different, right? And the security model needs to be different, and the paradigm, the programming paradigm, the mindset of the programmer must necessarily be different, because we're operating under different security constraints and different attack vectors. And therefore, we should only support domain-specific languages, so things like Solidity and Viper, and require programmers to learn the language and the framework together, right? And of course, the opposite school of thought is what you're suggesting, which is that we should make use of existing tooling, general purpose languages, right? So I'm just curious if any of you, which side of that do you fall on?
So I kind of disagree with like the way you put that question. So actually, it's so the thing is that I can definitely agree that it's very desirable to have like domain-specific languages, like formally verified languages. But on the other hand, we are speaking about execution environment, execution platform, which should not require anything, but should like provide as much like leeway, as much as possibilities as it can. So it can developers on that, like developers of tooling for that platform can have like very broad set of like possibilities. And if you like require everyone to have formally verified language, or for example, if you like narrow the scope of your virtual machine. For example, we already have Bitcoin, for example, and it has a virtual machine, but it's like it doesn't support use cases that, for example, Ethereum can support. And it's not like that bad thing, but it's like a, it's about extensibility and universality of platform. And I would like to see like more languages that actually formally verifiable and domain specific that compile it into this WebAssembly platform. And yeah, it's actually very desirable.
Well, one thing which is usually never really mentioned is a lot of like general purpose programming languages which have really good metaprogramming features, and therefore, kind of like DSLs can be introduced in them. And none of these languages would be compiling to EVM ever, because they're general purpose. They're way too complex. But you can also find the sweet spot of using this general purpose language, which has a lot of experience and expertise behind it, and use the metaprogramming on top of it to present your subset of the DSL you want to present to the developer. What DSLs are mostly about is just restricting the developer what they can do. That's the whole goal. And that's what we have been doing with less or more effort. And I'm kind of middle, so I do like DSLs for specific use cases. But I do see a lot of opportunity for high-performance code where there's no need for the DSLs. And just in general, we really have been trying to educate people into this blockchain context by giving them this restricted view, and at the same time trying to invent this new language for them. It's a lot to do at the same time. So maybe by utilizing this common ground, which hopefully going to be a much better space, as Sergei said, for much better breeding ground for new languages. I hope that we're going to see a new set of different domain-specific languages coming to life, targeting WebAssembly, because they can be domain-specific for specific use in the web. They can be domain-specific for specific use in Substrate, in Polkadot, in Ethereum itself. I think that's one of the really huge benefits, and that's the part I'm excited about. But then also, because I'm really part of Solidity, I'm kind of attached to Solidity a tiny bit, or that's what I get usually, that, okay, you don't want Wasm because you're a Solidity guy. I think Solidity did its job really well so far, trying to explore all of this, but it still has to do a lot. It has to still evolve. And I think Wasm is a part of that evolution. And by enabling, enabling Solidity on Wasm, we're going to get a lot more people involved, and which hopefully going to help the language to evolve even more. And maybe it's going to be a really good DSL in the future, targeting Wasm. Maybe not. But the door will be open to anyone to do that. And it's just one last note on languages on EVM right now. There are a lot of different people coming up with new language ideas. And many come from the formal verification background. And since EVM is so restricted and the community is so small, they start to work on it. They spend 2-3 months. They get to a basic working version. People get excited, and then they disappear, or they get busy with something else. They may not be able to get funding because the space is so small. So I think with Wasm, that's going to change.
Mm-hmm.
Sorry, go ahead.
Yeah, so I agree with many of the points, but I think there is, in total, so we have this execution platform, the Wasm execution platform, and then on top of that we can do many different things. So as mentioned, we can have domain-specific languages that kind of make sure that there is certain kind of bounds on the usage when using this particular language. We can maybe adopt existing languages because they already compile to Wasm in order to be kind of better suitable. And then what is really nice is we can leverage the kind of the tooling or the knowledge that people have about developing in those languages. But generally speaking, so what is something that is the case, for instance, in Substrate or Polkadot is that you can also place the level of kind of abstraction or the thing that you are actually taking care of when you're writing smart contracts a bit higher. So have this execution environment validate only certain certain kinds of state transitions. So what that makes possible is actually not only restricting people from, because I think there are some voices maybe outside of the WAS for Web3 community that say, hey, maybe you know, even if you have one language, still by making this underlying state machine so permissive, you are introducing lots of vulnerabilities. But you can also say, hey, actually we restrict that particular chain, and with Substrate you can say, hey, the state machine only supports executing that particular language or that particular subset that makes or that particular execution model that makes things secure. So, but as you guys said, like it's great to have possibility and ability to explore all those different avenues, and Wasm is really this low-level component that is very performant, that is as close to the metal as it can be while still remaining abstract, and enables us to then move on into those different directions.
I think we can all agree that one of the main overarching goals of WebAssembly for Web3 initiatives, so kind of jointly, right, is maximizing optionality. And this goes back to something I think both Alex and Sergei touched upon this. It's not the case that one size fits all for, like, let's say, smart contract programming languages. And we probably want to have a lot of evolution in different directions so that you can have different languages, whether they're general purpose languages, whether it's general purpose languages with frameworks bolted on, whether it's domain-specific languages for different use cases. So super consensus critical stuff, maybe in the case of Ethereum, you know, we'll want to do that in something like Solidity for some time, but I can envision many other use cases where we'd want to use other general purpose languages. Mm-hmm. I want to focus a little bit on the sort of the subset of the language, the subset of let's say, the instruction set, which you touched upon a moment ago, Peter. Let's start with, like, what is the relationship between Ewasm and Wasm? What does Ewasm add or remove from Wasm?
Yeah, Ewasm is Wasm. There's no change. There would be no point removing or adding anything. We mentioned this so many times already. Ewasm is designed to be extensible. So whatever we need to expose to Wasm contracts can be done in a standard way. We don't need to invent anything. So that's what Ewasm is doing. It's exposing these state accessing and state modifying features to Wasm in a standard way, how Wasm is designed. But Wasm does have one tiny, like, non-determinism issue regarding floating point, which probably Sergei can go way more deeply into explaining it. But in practice, what we do is we disable floating point. And what that means is when somebody deploys a contract, that contract goes through a verification process. And if that verification process finds that the contract is using floating point, then the contract is rejected. It's not deployed. And that's it. There's nothing to be done there. There's no special tool needed to transform your code in order to deploy it. In many cases, in compilers, you can instruct the compiler not to use floating point. Or first of all, if you don't use floating point numbers in your source code, very likely the output will not use floating point. But in some languages, some compilers it may, and then you may need to instruct your compiler to avoid doing that. But interestingly, also many compilers have like a soft floating point option, so you can use floating point in your source code, and the compiler will generate code which deals with that. And that would be accepted. But yeah, Ewasm is Wasm. There's a verification. If you do something we don't want you to do, we don't let it to be deployed. And that's it.
The funny thing that we actually don't remove that feature, like floating points. We're just building a verification on top of the Wasm standard verification and just reject like modules that have floating point operations. So basically that means that we use fully compliant Wasm VMs for executing Wasm. And actually this problem, problem with determinism can be like circumvented by just like coming So it's the floating point operations are not deterministic in some situations, but we can define the semantics of these operations that to be aligned with exact for example, with some alignment with some platform like Intel's, which is super more common, and for other platforms we can just canonicalize these floating point operations, and it will work, although a little bit less efficient. Yeah.
Mm-hmm.
Yeah,
more generally, kind of what the problem is, maybe for people not familiar, is that when WebAssembly normally runs in the browser, then there are some behaviors, or like the way the computation goes does not have to always result in exactly the same thing on each person's browser, because it's usually kind of in the context of how it was kind of originally developed is just to perform some local computations that are there to display certain things, or kind of just do things locally that other people don't have to trust. And in the context of decentralized web, we want this execution environment to be a way to kind of deterministically specify computation. So basically make sure that wherever someone runs it, as long as they agree on the same way to execute this code, they will always arrive at the same result. And this is crucial because this is what enables us to achieve consensus, for instance, on the blockchain, that a particular result, that we achieved a particular result of a computation. So we need to slightly, as you guys said, maybe not really modify, but reject certain elements that can introduce non-deterministic behavior that would result in different stuff on different devices.
Well, actually, if you stay with this single example, so on the technical level, one of the problems with floating point is that the representation of not a number value in floating point can have like two different values at least. And the reason for that is Intel chips and ARM chips use different values, and Wasm is designed to be like translated to these chips. And if you would choose one, then you couldn't translate it to both chips at the same time. And that works well in the browsers. It's performance related. Now, in the blockchain context, by just rejecting contracts using them, it's fine because there's no need for it right now. But if the need would arise to support it, there are many different ways to do it. So what Sergei said, you could, for example, you could just take Wasm as a blueprint and not execute Wasm itself, but you take it as a blueprint. This is the instructions we're going to do, but you specify the semantics how those instructions should actually operate. So in that case, it's not entirely a Wasm VM anymore, but you still leverage of the compilers, and you leverage of Wasm as the medium of transform of the computational, the description of the computation. But you could also transform that Wasm bytecode and insert like special instructions to canonicalize, to change the value after each of those like potential instructions resulting in none. So there's a lot of different ways to do it, and all of these are open. But I think in a blockchain context, today we just chosen to reject such contracts because, okay, there's no need yet. But if there would be a need, plenty of options.
Cool. Yeah, thanks for sharing those thoughts. I want to change gears slightly and touch upon the topic of security, right? Because in the Web3 blockchain world, we're operating in an adversarial environment, and this sort of has to be one of our main design considerations. And some extremely experienced people have raised some questions, right? So Greg Colvin, who's an Ethereum core developer, has sort of made the point that like if a program is running inside a browser tab and someone somehow gets a piece of malicious code in there or something that causes your CPU to spin, it's not a big deal because your browser tab freezes and you can close it or kill the browser. Obviously, in the context of blockchain, like that's a huge problem because every node in the network would stop working if that were the case. There was also a very interesting thread with Brendan Eich, who's the inventor of JavaScript and, of course, more recently leading the Brave browser project a few months back on Twitter. And he asked the question, is Wasm the right choice for blockchains? Does it not introduce unneeded complexity and just a broader attack surface? So I guess the question I have for anyone is how confident are you that it's the right choice and that it's going to be secure?
So first, about Greg Colvin's concerns. I believe he was concerned about that Wasm compilation can lead to something called cheat bombs that actually, so time spent on compilation can be non-linear or like quadratical or like worse than that, and it can it can take like a lot of memory and CPU resources to just compile it. Yeah, this is actually a problem, and we have to deal with it somehow. And like, I would start with something that compiles Wasm code in one pass, and actually it's a common technique, and it's used in, I believe, like in most of browsers, like nowadays. Like certainly some of them uses it, like at least V8 and with their lift-off and SpiderMonkey from Firefox, and so we can just use such approach. And yeah, but then we can do better than that. So, for example, we can start exploring the space, like how much, what the, I don't know the word, biggest code quality you can get spending only linear time depending on code size to get like the highest quality code that you can. So we can, like, there are some papers, we can like just tap on them and see what they can provide and with what like limitations. Yeah, but we also can go and research in a kind of different direction. For example, do we actually require a linear price per, like linear pricing of like compilation? Maybe we can come up with something different that will more like reflect more accurately the actual price. Yeah. For like, I mean, for current, for common current compilation techniques. Yeah, this is a very interesting space.
Yeah, we have a lot to research and learn in this space. Any additional thoughts?
I have an addition on.
Just go ahead.
Just in the context of, so the major concerns Greg had are really valid concerns, as well as like Sergei explained. But they really stem from the background where it wasn't fully clear that we are not really targeting web browsers. And most of this was really in the context of web browsers. And then we rely on third-party WebAssembly engines. We have zero control of, and they may do whatever optimizations. And many of those optimizations very likely have nothing to do with blockchains and or may be counterproductive to blockchain use cases. One thing which since then probably became more clear in the ecosystem, that Wasm is really just the blueprint. And in a consensus setting, you maybe want to write your own implementation of a Wasm VM for your client. And that's what Parity has done. They have their own version of a Wasm implementation. And very likely that is probably the end goal for consensus nodes, that you have this well-known, proven, for that given goal designed VM, but still conforming to Wasm, which is not affected to any of these problems. It may not be a JIT, it may not be that performant, but it is accomplishing the goal of a stable consensus engine. And then on the user side, the user is free to use whatever. They can use the browser, they can use random JITs and really high performant ones. And most of the computation should happen on the user side anyway. So the consensus layer should only handle a tiny bit of computation, where a slower but 100% correct engine is good, and 99% of the computation going to be at the user, where it doesn't really matter too much if the engine has a problem, because the same example from Greg, it doesn't matter if the user's tab just blows up. Yeah, the same applies here. But true to be said, this is, I think, like the end goal all of these blockchain projects should strive for. But the reality today may be different. So in the reality of Ewasm is it uses different clients, it uses CPP Ethereum, Go Ethereum, different engines. So we try to benchmark and research all of these different engines and look into vulnerabilities into them. And we especially looked into JIT bump issues, and which we actually did prove that, yeah, it's a problem. We were able to find a bug. And what JIT bump here means is you have a tiny bit of code which blows up the execution time in the JIT engine. And the execution time in the JIT engine usually has two parts: compiling that code into machine code and then executing it. And what blows up is this compilation process, is what can be blown up. And there's ways to craft special code which does that, which is tiny. So you're going to cost you 2 gas to deploy it, and the blockchain dies. So that's a real problem. But I think in the long term, it's not going to be a problem.
Yeah, and all of this only concerns the trusted code. And for example, if we're speaking about, for example, Polkadot or Substrate, where we're dealing with mostly trusted code, then we can use, it's not a problem at all. We can use whatever engine we would like, even very highly optimized LLVM builds at maximum settings or something like that. Yeah.
So one on the performance side, I think there are some really interesting optimizations that can be also done. Something that Parity does with compilation, because many programs that compile to Wasm can also be compiled to native code by relying on a reliable compilation, or you can try to do some optimizations where given a known source code, you can try to instead execute the native code, because usually the transformation that would the difference between the Wasm code and actual native code is fairly small, because they are kind of fairly similar to each other in many respects. So that's on the performance side, but also something that is also on the performance side, but also addresses what Brennan was saying on Twitter, is that as I mentioned before, you can this is just the execution layer, and it's a fairly low layer that we all agree on, and actually, if we would like to have very kind of secure computation models on top of that very low layer, we should do it. We don't have to. The only difference is basically that now this secure computation model is kind of canonically defined in Wasm, rather than just compiling to native. And it's not really a big difference. We still can have a very kind of bound and locked down kind of computation. So I don't see kind of, I think maybe his argument is more against this kind of, hey, let everyone use their raw Wasm execution environment for writing stuff that runs on chain. And obviously first of all, there are certain limitations that involve, things like metering, making sure that there's not too much computation done, but also can involve even introducing higher levels of abstraction. And for instance, with, as I mentioned with Polkadot or Substrate, really the WAS part is there to verify what the stuff that went on chain, not directly, at least in most cases, not directly verify the smart contracts. There can be chains that have this feature that allow people to write raw WASM, but in a general case, or the cases that, for instance, we saw that Gav showed yesterday, it was just some game, and the only actions were like 2 actions that you could perform. You couldn't access all the WASM opcodes to kind of run your application.
Cool. I want to save some time for audience questions, so let's go to audience questions. We have a mic here. Anyone have any questions?
Hi, thanks everyone. I was curious if anyone has heard of or has thoughts on this question of like a safe subset of Solidity. So we could talk about subsets of JavaScript that people think like, oh, this is what we should use to like avoid some like more crufty parts. So I was wondering if anyone has thoughts on sort of a similar subset for Solidity.
We all look at Alex.
Well, don't use assembly, first of all. And don't use any of the low-level functions. And read the documentation really well, because the documentation is evolving a lot. And know all like the subtle details about all of the different types, because there's a lot of detail hidden there, and the documentation now is extended to, in the type section, to have all these subtle details. So like one thing people don't really know is, the unbounded nature of mappings and arrays, and that they could overlap because they're just hashes. And certain things about like variable length arrays, the way you can increase them or decrease them. You may do an overflow, and suddenly you have like a 256-bit number of items. There's a lot of mistakes you can do. So the first thing, just read the documentation to understand all the types, and be really careful. There's no real subset, because it's already such a subset of what you can do.
Hi. Hello. So thanks for the talk. I'm wondering which features of the Wasum Roadmap you're following most closely, and what the communication looks like between Wasum and your respective groups.
Features of the Wasum roadmap that we're watching most closely. I'll just throw out garbage collection. I mean, that's a huge one that would enable a lot of things that aren't possible today.
So the question was about whether we are tracking
which features of the Wasum roadmap are we following, and then also do we have communication with the Wasum project?
Okay, so yeah, we kind of tracking some features for at least Ewasm and like Wasm in Parity in general. And like the most, so I personally waiting for multi-value return types just because sometimes you actually need them, and like for now you just have to create your APIs in such way that if they actually require to return multiple values, you have to return one value via like usual return value, and the other one via memory, which is not a good API design. And we are talking about like API design in blockchain space, which basically means that is cemented for a long time. Yeah, and another thing that would be helpful, but it's not a real feature per se, like in the roadmap, but it's more of like a bunch of features. It's like features that would be able to do us dynamic linking. And this is like very important for a platform that is general and and low level, because for example, EVM contains some hashing function, and like WebAssembly doesn't, and you can embed them in host runtime, but like it would be
standard libraries.
Second?
Or standard libraries.
Yeah, but if you enable it, like if you embed it in like standard libraries which compile it statically, then you will have them in every contract, and it would be desirable.
No, I meant dynamic standard libraries.
Yeah, exactly. That would be actually enable this. Yeah.
There's one more thing I'm personally interested in is type annotations. So types currently are just two types. Well, okay, floating points have like 32 and 64-bit as well, but just 32 and 64-bit integer types is what we have. Having type annotations would have an added layer of type safety on like the host functions we have. So for example, we have like this store host function, which does what store does in EVM. And that should have, two different types, like a key and a value. And you could have a type annotation for this. And of course, your compiler going to do all of this type checking for you. But if you have this added layer, we have added safety. So I think that's one of the more interesting features. And personally, not that interested in GC itself, because that's a lot of work to get it right.
Just me.
Yeah.
Do we have time for a couple more questions, or are we out of time? OK, let's do one more question.
Hello. I have a question about storage, specifically program storage. So do you have any estimates on how switching to Ewasm will affect the program size? Because EVM is currently very limited. Developers know the entire instruction set, so it kind of forces you to think in optimization down to a single instruction. And with general purpose programming languages, can it lead to explosion in size? Do you have any estimates or benchmarks?
So how does Wasm change how we think about storage in the blockchain? Are we concerned that compiling general purpose languages to Wasm will cause the byte code size to explode, for example?
It does.
Yeah, it does. Basically, because so as I mentioned in the previous answer, we would really like to get dynamic linking to offload some of commonly used code, and that will make binary slimmer. But yeah, for some cases, EVM code is much slimmer than Wasm code.
Yeah, well, I guess for most of the cases, really. So yeah, it's going to be bigger. But standard libraries and regular user-provided libraries, all of these dynamically linked, that's going to be the next evolutionary step needed to keep the size small. But then people still need to come up with these good libraries which are used by a lot of contracts. So they're going to be a challenge. I think eventually, I don't think we can ever really get near entirely to the bytecode size of EVM because it's highly optimized, but we can get close. Probably it's going to spark different ways of programming and designing contracts and libraries. So probably in the future, after all of those new concepts emerge, it's not going to be a problem. But in the short term, probably it's a problem.
Yeah. And it's generally a problem for blockchain, so we need to come up with more radical solutions to that problem anyway, to prevent bloat.
Cool. Well, hey, thank you for listening. Thank you for the questions. You can find us immediately following this in the Ask Me Anything corner in the main area. We will be hosting a 2-hour-long breakout session on Ewasm at DevCon next week, where we'll be publicly launching our testnet and some tooling. So that's on day 2. Please come find us there. And if people want to learn more about Wasm or Polkadot, where should they go?
There will be a Substrate workshop in the hackerspace. So you can check out, I think the time is written there.
Thank you.
Yeah.
Thank you.